Hello. Before we start, let's look at the roadmap for the journey we are going to follow. At the highest level, we start with AI or artificial intelligence, which includes broad concepts such as reasoning, planning, automation, expert systems, and intelligent agents. Inside that, we have machine learning, where systems learn patterns from data. This includes supervised learning, unsupervised learning, clustering, regression, classification, reinforcement learning, and so on. After that, we move deeper into neural networks, where models learn more complex relationships through connected layers of computation. From there, we get into deep learning, which allows us to work with more advanced data types such as imagery or satellite imagery, time series data sets, spatial networks, larger scale patterns, transportation network. This is where techniques like CNN, LSTM, transformers, graph neural networks become important. And finally, we reach to generative AI, including large language models, agents, multi-agents, retrieval augmented generation or RAG, multimodal AI, and AI systems that can interact with the special tools and maps, documents, and databases. But because this series is focused on spatial data, we are not going to study these topics in isolation. We are going to connect every concept back to spatial problems, such as maps, locations, coordinates, satellite imagery, road networks, buildings, infrastructures, and so on. In this first video, I begin with foundation, with the spatial data foundation. So before we can build machine learning models or AI agents or intelligent systems, we need to understand what is spatial data and how it is represented and why it is important and why it is different from regular tabular data sets. So in this introduction, we will cover the main types of spatial data, including vector layers, raster data, coordinate system, projections, and so on. By the end of this video, you should have a clear understanding of the data foundation that every spatial AI system is built on. So let's start with the introduction to spatial data. Okay, so this slide shows the full structure of the session or of this video. So spatial data is not just one concept or one topic. It is a complete ecosystem. So we have concepts such as geometry and relationships. We have systems such as spatial databases and indexes, and we have in practice we need to choose the right projection, we need to clean invalid geometries, and we need to select the right format. So these are main 11 components that help us to better understand spatial data. Types of spatial data, coordinate systems, spatial attributes, spatial relationships, spatial operations, spatial formats, databases, indexing, and real-world application. And at the end, the last component is about challenges and best practices in geospatial domain. So we can start with the first item. We can start, okay. Now let's start with the first component. What is the spatial data? So at first, it sounds simple. Spatial data is a data uh, about location, but the moment we start using it in analysis, we realize that it is much richer than that. So location is only the start point. Spatial data also includes geometries, shapes, distances, directions, adjacency, containment, overlaps, intersections, movement, um, and trajectory or time series problems. So this section gives us a basic definition that everything else will build on top of that. So we're gonna answer two main questions: where and how. So this table at the bottom shows um, the difference between normal data and spatial data. So we have, for example, in our database we have customer name, If it's spatial data, we have customer location. This is just a simple example. For each customer, you would have latitude and longitude. Or if you have road condition, in a spatial database, you would keep road segment geometries. This is going to be a line string. We have building asset ID. Then for a spatial data, we would have building in 3D space. So we have footprints and height. If you have weather reading in the spatial data, you would have reading at coordinate plus time, x, y, and time.